Hello YouTube, De-bodgery here, aka Richard Gumfaw on Facebook. Yep, same guy, not Matt Waters from EBMX in any way. I'm in the US and he is in Australia. So this is a KO Pro controller. So there you go. I bought this with my own money. I bought it from EBMX, but I bought it. Not given to me, not free, paid for by me. Alright, so I have no affiliation with EBMX other than buying controllers from them. Alright, this video is going to be about current path, power stage, that kind of thing. Alright, so first thing I want to talk about is these little areas right here. So there's no circuit trace right here, and that is so that those washers on the M4 screws can press down right there and not have a current path from here all the way through to the heatsink. Which is good, because you don't want a dead short, and that would definitely create a dead short. However, that's also bad because now you're not using these screws as a current path. And if it was designed a little bit differently, those screws could have been part of the current path for bringing battery plus and battery minus up to the logic board. And I can tell you that the current path needs help, and these could have been used. The white stuff on them, by the way, is thermal paste that is not Loctite. And the only thing that keeps these screws tight is a split washer, lock washer on there. So can they work loose? Oh yes, definitely they can. And the other part of that is there's also these three really tiny M3 screws that help secure the logic board to the power stage. And they also have no Loctite on them, so yes, they too can work loose and then rattle around inside and create problems. So the method of securing the logic board to the power stage is meh. Yeah, definitely a problem waiting to happen. And good luck getting KO to even acknowledge that that's the case. Never mind do anything about it, because KO cuts corners. I'm going to have to come up with some clever thing for KO, but yeah, corner cutting is the name of the game for them. It is a Chinese company, and as is not unusual for Chinese companies, they are always looking for ways to cheapen manufacturing in any way possible. And, well, that is definitely the case here. Everything from Chinese capacitors to brass rather than copper standoffs to, not using copper reinforcing and everything else. Yeah, this is awful. As far as the current paths are concerned, other areas are okay. Chinese caps, that's, well, come on, that's not import. That's import from China to China. Sorry, that's not a high-grade component. That's a cheap one. The current paths on here, so you can't really see it on camera. I can do a macro video or macro lens video later on so you can see these things much more clearly. But there is a paper thickness circle on these pads, and that is the current path from these pads to the brass standoffs down here. So yeah, it's not a very large surface area here anyway, because it's pretty thin brass, but then it's even thinner when it gets to here because it's literally just a razor's edge kind of contact area. And then of course with no copper reinforcing, you're getting a lot of heat here, because this is like the battery plus. That's like where the mass amount of battery plus current passes, and it's only got two standoff points on either end, which are already high resistance because they're just a butt joint. And then there's no copper reinforcing, and then you have a thin spot in the middle. Battery plus bus on here is going to get pretty warm, and all that's going to do is cause these capacitors to get hot, and they don't like heat anyway. Electrolytics don't, and that's why they have these score marks in the top of the aluminum can, so that they can crack open rather than explode. And when they do that, well, they're not capacitors anymore. So these capacitors will have short lives just from heating, not from anything else like being, I don't know, cheap Chinese capacitors. So anyway, enough of that. The power stage is fraught with really awful design choices and cut corners and cheap things done. Something that I said on Facebook, and I was wrong, was that there was no battery plus bus on the power stage. And in fact, there is one. It's just not a very good one. So in their pictures, you can't see it. I can because I'm looking at it, but it's probably not going to show up on camera. But so here's one standoff, Here's where battery plus comes in. Here's another brass standoff. And then there is a circuit trace that runs all the way across the top of the board here underneath those MOSFETs. And it's about, I don't know, 10 millimeters wide or so. But it's just circuit trace, typical circuit trace thickness. It's not even like double thickness or anything like that. It's very, very thin. And it's completely inadequate for the battery plus bus. Never mind that this too is also equally inadequate, and no way in hell will this ever handle the current that KO claims, because there's just simply not enough copper here for that by any stretch of the imagination. This will create a hotspot, and it's right on the backside of the MOSFETs where you don't want heat anyway. So yeah, bad design, and I've already said all that stuff. Right here, here, and here are the 3 phase buses between the banks of MOSFETs. And as you can see, there's no copper on them. At least these 2 here have bare circuit traces with a little smattering of solder on them, but that's going to help marginally. And this one here has none at all. So, yeah, supposedly 800 phase amps are going to sit there. Not a chance in hell. Never going to happen. Those bits of copper on the circuit board will literally explode in flames before they will ever tolerate 800 phase amps for more than like a millisecond, and certainly nothing even close to that continuous. Yeah, that's pretty shoddy work. You pick up a 4,000 watt controller and you will see copper on the phase buses, and there's none, and this controller is supposedly, you know, a lot more wattage than that. These bridges, supposedly KO, they love to brag, has patents on those things. All I can say is smirk. Really, guys? You're going to patent a shitty design? Good job, guys. Yeah. Up here, the solder pads on this end, they are 2 millimeters wide by about 6 millimeters long. Heat cycling on these bridges, never mind vibration, is going to cause those solder joints to break loose. So yeah, you're going to see failures at the tops of these bridges, and also that power bus right there for the phases, that's going to get hot anyway, which is going to just accentuate this problem, and those will break loose. The other end is soldered down pretty good, so that's probably going to last. Won't really have a problem with that. All of the buses that are here are sections of, you know, essentially scrap pieces of copper as far as I can determine. So like this is the battery minus bus through here, so you've got 3 standoffs, and then this is where battery minus comes in. So the copper all the way through here doesn't even touch. So you've got gaps between the brass and the copper, a little piece of copper here, and a bigger piece of copper here, gap, 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 big gap, big gap. Yeah, you might as well just not even bother with the copper on there, because, well, you completely eliminated its whole purpose by having these giant gaps between the places that got to carry current. Right. Yeah, and the battery plus bus, it doesn't even have copper on it. It's even worse. So, yeah, this is a bad design. All of these brass standoffs, yeah, you can see they're just soldered down. There is no like screw, and you couldn't have a screw anyway, through the bottom or something like that to screw them. They're literally held down by solder. That's it. So if you were to crank on these too much, you would twist them off. And if you did that, you would at least break the solder and probably rip up the trace underneath. Here is one of their screws that goes into those things, and it's got a Phillips head in it, so it's going to cam out most likely before you crank on it too much. So that's their safety, KO's safety to you over cranking on these things, is by using a Phillips head screw rather than a hex head or Allen head. And in fact, I've seen a support comment from KO to someone where they talked specifically about not using hex head or Allen head screws, and that you should put Loctite on these threads when you put them in and only tighten them up a little bit, which means that when you put the ring terminal down on here and then clamp it down with that screw, you now have a high resistance joint between the screw, the ring terminal, and the brass. And I have also seen some pictures of one of these exact same controllers where all of these things were just thoroughly scorched because the screws simply couldn't clamp down tight enough on the ring terminals to make a low resistance path from here to the wires for the motor. So yeah, this is a problem. just because you can't screw them down tight enough and they're soldered down rather than reinforced some other way, like say EBMX does. You know, they actually have this single piece of CNC machined copper, not brass, which costs a lot more, by the way, and it's got screws securing it down, not solder. So yeah, it's going to hold up, and they have no recommendations about cranking on those things. Crank them down. That's basically it. Yeah, and I will show all that stuff too. So there is an aspect of this board that I do like, and that is these two little guys right here. So the pins are long and they're flexible, so thermal expansion contraction is cool. The logic board and the power stage will expand and contract at different rates from each other, so the fact that these can flex is excellent. That was a good idea on their part. Also, the bottom of the connectors are not just soldered down, they are glued down too, so that's good. You can see it probably a little bit better on this one. Yeah, so you can see that white stuff on there. Oh, never mind, I was wrong. I thought that was glue. Never mind, I lied. That is thermal paste that is seeped up through a hole in the board and kind of oozed out around the connector. I thought that this was some kind of a glue that was on the bottom of these connectors, and it's not. So never mind, they didn't put glue on those like I thought they did. That is just soldered down. So yeah, I was going to say I like that too, but nope. Nope, I was wrong. Yeah. By the way, all these MOSFETs, these are JMJ Chinese MOSFETs. They are not imports like, say, IXYS or AOT or Infineons. They are Chinese MOSFETs. On Facebook, I'm pretty sure is where I saw this. KO was trying to slam EBMX for having tantalum caps, or so-called needing tantalum caps, on their power stage to handle noise, and yet look what's right there. KO uses them too, and by the way, that's a pretty standard thing. It's not unusual and it's not a bad thing. It's something you have to deal with, is you know, ripple and high frequency noise. So yeah, you need tantalum caps on your power stage in order to control that, and KO's got them, and so does EBMX, and that's very, very normal. But KO, blowing smoke out their asses like they typically do, said that's bad, and showed them on the EBMX power stage, and completely ignored the fact that they too have them on their power stage. So yeah, KO lies out their ass all the time. They make misinformation comments all the time, and yet, you know, here it is. All I can do is show it to you and show you the craptastic work, and this is exactly everything that I said on Facebook. You know, this is the exact same shoddy work, exact same crappy construction, crappy design, underpowered buses, everything. This is awful. Don't buy KO. This is terrible.